A silence older than memory fills the void. The cosmos stretches outward in every direction, a canvas so vast that even imagination bends beneath its weight. Stars flicker like fragile embers adrift on an endless black sea, each one a fire that has burned for millions, sometimes billions of years. And yet, when seen from afar, they tremble as if uncertain of their own existence. It is within this trembling light that a question emerges, a question both ancient and newly born. What if these suns, these galaxies, and the very threads of space and time are not the foundations of reality, but shadows of something deeper? What if every atom, every law of physics, every echo of gravity and light is no more than a reflection cast from a world hidden beyond our reach? Reflections in water distort the image they mirror. Shadows on a wall stretch and twist as the source moves unseen. Perhaps our universe is much the same, a faint silhouette of a truer existence, its form warped as it filters through unseen dimensions. For centuries, humanity has turned upward and asked what lies beyond. Heaven, void, eternity. But now, the language of physics itself begins to whisper the same haunting suggestion. Quantum mechanics, relativity, the strange silence of dark matter and the relentless pull of dark energy, all hint at something unfinished, as if we are glimpsing only the edge of a greater design. And so the unsettling thought takes root. The stars may burn above us. Time may carry us forward. Yet what if none of it is primary? What if our universe is not reality itself, but only its dark mirror? In the first years of the 20th century, science found itself standing on the edge of a precipice. The Newtonian world of certainty, where planets obeyed precise equations and falling apples revealed the secrets of gravity, was beginning to fracture. In its place came visions of a universe stranger and more fluid than anyone could have foreseen. Albert Einstein's general theory of relativity arrived in 1915, a revelation that space-time itself was not the silent stage on which the universe performed, but the very fabric of existence, bending and curving beneath the weight of matter and energy. Space could stretch, time could twist. The cosmos was alive, dynamic, a great ocean of geometry and motion. Gravity was no longer a force pulling objects together, but the bending of the stage itself, reshaping the dance of planets and stars. At the same time, another revolution brewed in the shadows. Quantum mechanics emerged from the puzzling behavior of light and the strange quirks of subatomic particles. It spoke of dualities that defied common sense. Photons that were both wave and particle. Electrons that could exist in many places at once until observed. Reality itself seemed to dissolve into a haze of probabilities. The smallest building blocks of existence whispered of multiplicity, as if each particle carried within it the hint of other possibilities, other reflections. Physicists, confronted with these new worlds of relativity and quantum theory, began to notice patterns that seemed almost too neat, too symmetrical. Forces balanced against one another with exquisite precision. The strengths of the fundamental interactions, the masses of particles, the exact values of physical constants, all appeared tuned with uncanny delicacy. Why, they wondered, should the universe be arranged so perfectly for stability, for complexity, for life? Was this harmony a coincidence, or did it point towards something hidden, a structure beyond what could be seen? In 1928, Paul Dirac put ink to paper and gave shape to an equation that would deepen the mystery. Seeking to reconcile quantum mechanics with Einstein's relativity, he discovered that the mathematics insisted on a strange symmetry. For every electron, there had to exist a mirror partner, identical in mass, but opposite in charge. At first, the idea seemed like a mathematical curiosity, a ghost conjured from the algebra of the universe. Yet in 1932, the positron was discovered, proving that antimatter was real. The cosmos held within it a silent reflection, a shadow partner for the particles of the ordinary world. This revelation sent tremors through physics. If matter could have a twin, unseen and unsuspected until the right conditions revealed it, Could entire worlds also have twins? Was the universe we know only half of a greater whole? The symmetry written into Dirac's equations suggested that reality might be deeper than appearances, that existence could unfold in pairs, reflections, and hidden counterparts. As the century advanced, these suspicions grew stronger. Particles were found to arrange themselves into families, grouped in ways that hinted at hidden order. The neutron, once thought indivisible, broke apart under the gaze of particle accelerators, revealing quarks arranged with mathematical precision. The forces of nature, gravity, electromagnetism, the strong and weak nuclear interactions, bore signatures of symmetry, as though cut from the same cloth, then folded and twisted in ways that science could barely trace. Yet even in this symmetry lay strangeness. For nature did not always honor balance. In some experiments, particles preferred one orientation over its mirror image, breaking the neat rules physicists had expected. The universe revealed itself as a place where symmetry existed, but only incompletely, as if the reflection had been partially erased, half hidden behind a veil. And so a question began to form in the minds of scientists and philosophers alike. If particles themselves carry shadows, if forces and constants whisper of balance beyond sight, then perhaps our entire cosmos is only one face of a deeper truth. Perhaps, just beyond perception, another reality mirrors our own, containing what we lack, completing what seems broken. These were only the first whispers, faint and uncertain, yet they would grow louder with each passing decade. The revelations of relativity and quantum mechanics did not merely reshape science. They unsettled the very ground of reality. They planted a seed of possibility, that what we call the universe may not be singular, but one reflection among many. And like all reflections, its existence might depend on something unseen, something watching, something casting the shadow we call home. By the middle of the 20th century, physics had become a cathedral of symmetry. From the smallest particles to the structure of the atom, the universe appeared to obey rules that reflected balance and order. Forces were paired, charges were opposed. For every particle, there was a partner, like dancers in a cosmic ballet keeping step with one another across the stage of space-time. Physicists believed in parity, the expectation that nature should not prefer one side over another. Just as a mirror reverses left and right without altering the essence of an image, the laws of physics were assumed to be indifferent to orientation. If the universe were flipped, reflected like a photograph turned backward, its motions would remain unchanged. This faith in symmetry carried a quiet elegance. It reassured scientists that beneath the chaos of nature lay a deeper perfection, an impartial order holding everything in place. But the comfort of that vision was about to fracture. In 1956, two young Chinese-American physicists, Tsung-Dao Li and Chen-Ning Yang, questioned whether the weak nuclear force, one of the fundamental interactions governing radioactive decay, truly respected this sacred symmetry. Their proposal was daring, even heretical. For decades, parity had been treated as untouchable, a pillar of physics. To suggest its violation was to risk unraveling the very harmony of the cosmos. Yet the universe, when asked, gave a startling reply. At the National Bureau of Standards in 1957, Chen Xiongwu conducted a meticulous experiment using cobalt-60 atoms cooled to near absolute zero. As these atoms decayed, they released electrons. Wu and her team measured the direction of their flight. If parity were preserved, the electrons should emerge with no preference for left or right, forward or backward. But the result was shocking. The electrons consistently flew in a left-handed direction. Nature, it seemed, had a bias. The mirror was broken. The discovery sent tremors through the foundations of science. It revealed that the universe, at its most fundamental level, did not honor perfect symmetry. The weak nuclear force preferred one orientation, one-handedness, over the other. Parity violation was no small crack in the wall of physics. It was a gaping fracture. It meant that reality itself could be tilted, unbalanced, incomplete. This was more than a technical result. It was a philosophical wound. If the cosmos could show preference, if it could favor one side over another, then the dream of a perfectly mirrored, perfectly balanced reality dissolved. The universe was not a flawless dance. It was lopsided, distorted, as though half of its reflection had been erased. Physicists began to wonder if the symmetry they had believed in still existed, but elsewhere, hidden from view. Perhaps our universe carries only one side of a deeper equation, while its missing counterpart lies beyond reach. If the weak force in this world is left-handed, perhaps in another domain it is right-handed, restoring the balance we cannot see. This unsettling thought deepened as particle physics advanced. In the strong nuclear force that binds quarks together, symmetries still held, as though mocking the broken order of the weak interaction. Some forces reflected balance, others rejected it. The patchwork nature of these laws suggested that reality was neither fully whole nor entirely fractured, but suspended in an uneasy in-between. The human mind, craving order, could not help but imagine what was missing. It was as if the universe had shown only half of its face, the other half concealed behind a veil. Could there be an unseen twin realm? One where every broken symmetry is made whole, where right-handedness reigns where ours falters, where the reflection completes the picture. If so, our cosmos would not be the full story. It would be only half a book, half a song, half a mirror. A shadow world might exist beside ours, invisible but essential, carrying the symmetry we have lost. For humanity, this realization was both humbling and haunting. The universe, once thought to be a cathedral of perfect order, revealed itself instead as an unfinished structure, a leaning tower built upon missing stones. To live within such a cosmos is to dwell inside an imbalance, to know that something vital is absent. And so, the suspicion grew stronger. If nature has left-handedness here, then somewhere, perhaps beyond the horizon of perception, there must be its opposite. A hidden cosmic twin balancing the ledger of existence. The mirror was no longer whole, yet in its fracture, it whispered of another world. By the final decades of the 20th century, science had begun to look beyond the familiar veil of visible stars. New instruments, new machines, and new questions pushed human vision deeper into the hidden fabric of the cosmos. The universe, once thought to be mapped by light alone, now revealed that its greatest secrets resided in the invisible, the silent, and the ghost-like. The first whispers came from particles that barely seemed to exist at all. Neutrinos, tiny, nearly massless, and endlessly elusive, stream through every human body by the trillions each second, born in the hearts of stars and in the furnace of the Big Bang. For decades they were believed to be weightless, silent, messengers that barely interacted with matter. But experiments in the late 20th century revealed something uncanny. Neutrinos oscillate. They change identities as they travel, shifting between flavors, electron, muon, and tau. This quiet transformation hinted at a reality stranger than expected. To oscillate, neutrinos must have mass, however slight, and their ability to drift between states suggested a hidden connection, as though they were slipping across unseen dimensions, touching realities beyond the ordinary. These ghost-like particles became more than curiosities. They became clues, delicate, intangible signals that the universe held layers not yet understood. While neutrinos whispered of hidden properties, another mystery shouted in silence. Galaxies, when observed with precision, spun too quickly. Their stars should have been flung into the void, yet something unseen held them together. Astronomers named it dark matter, invisible, untouchable, yet outweighing all visible matter by a factor of 5. No telescope could capture it, no experiment could grasp it, but its presence was undeniable, traced in the gravitational embrace that kept galaxies whole. Dark matter became the loudest clue in the cosmic riddle. It was as if another form of matter, utterly alien to ordinary atoms, drifted alongside the known universe. Could it be that dark matter belonged to a hidden twin reality, bleeding its influence across the border between worlds? If so, every galaxy, every spiral of stars, would be shaped not only by what is seen, but by the gravity of an unseen mirror. The investigation deepened when scientists turned their gaze toward the oldest light in the universe. In 1965, the cosmic microwave background was discovered. The faint afterglow of the Big Bang stretched across all of space. At first it seemed uniform, a perfect echo of creation. But as instruments grew more precise, patterns emerged. Tiny ripples, subtle irregularities, imprinted across the sky. These ripples spoke of something profound. They revealed that the infant universe was not perfectly smooth but stirred, shaped by fluctuations that seeded the galaxies to come. Yet some of the irregularities hinted at more. Could these faint patterns be scars of interactions with something else in those earliest moments? Perhaps, as the universe erupted into being, it brushed against another realm, leaving fingerprints in the fabric of its first light. Together, these discoveries formed a chorus of unfinished truths, neutrinos that shift identities as though unwilling to remain fixed. Dark matter, invisible yet omnipresent, sculpting the grand architecture of galaxies. The microwave background, carrying whispers of ancient encounters. Each anomaly deepened the suspicion that what humanity sees is only part of the whole. Physicists, gazing into the data, began to wonder if their equations described only one side of existence. What if neutrinos oscillate because they reach toward states that lie outside this universe? What if dark matter is not exotic substance, but ordinary matter in another domain, glimpsed only through gravity? What if the scars in the microwave background are echoes of collisions between universes, brief touches in the dawn of time? The evidence did not shout answers. Instead, it whispered questions, faint and haunting, like voices in a fog. Every anomaly was a ghost, flickering at the edge of comprehension. And though each was incomplete on its own, together they suggested that reality was larger, stranger, and more layered than anyone had dared imagine. By the end of the century, science stood, humbled. The instruments had grown sharper, the mathematics more intricate, but the universe refused to reveal a final truth. It offered instead fragments, hints, and shadows. Ghosts in the data, reminding humanity that what is seen is not the whole of what exists. The suspicion that began with broken symmetries and mirror particles now grew into something heavier. Perhaps the visible cosmos, with its stars and galaxies, its light and its laws, is not the complete book of existence. Perhaps it is only one chapter, a reflection, a shadow cast by a deeper, hidden universe. By the closing years of the 20th century, the cosmos revealed yet another secret, one more bewildering than all that had come before. For decades, astronomers had believed that the expansion of the universe, born from the explosive violence of the Big Bang, would eventually slow. Gravity, they reasoned, must surely tug at the fabric of space, drawing galaxies back toward one another, halting the outward rush of creation. Perhaps, in some distant age, the cosmos might even collapse, in on itself, ending in fire and ruin. But the universe did not follow this expectation. In 1998, two teams of astronomers studying distant supernovae, dying stars whose explosions shine like cosmic lighthouses across billions of light years, made a discovery that shook the foundations of cosmology. The light from those supernovae arrived fainter than predicted. Their distance, their motion, told a story that no theory had foreseen. The expansion of the universe was not slowing, it was accelerating. An invisible force, stronger than gravity, stronger than all the known powers of matter and light, was pushing the cosmos apart. It was given a name both simple and haunting: dark energy. This force now accounts for nearly 70% of everything that exists, yet no one knows what it is. Unlike dark matter, it cannot be traced through the binding of galaxies or the bending of light. It acts not by pulling, but by repelling. driving the very fabric of space-time to stretch faster with each passing moment. Every second that passes, more space is created, and with it, more of this invisible energy in a feedback loop that ensures the universe will never cease its outward breath. For scientists, the shock was not merely in the discovery itself, but in what it implied. If such a force dominates reality, why does it exist at all? Why should the vacuum of empty space carry energy? Some theorists turn to the quantum world, where fields ripple with hidden fluctuations, even in the absence of particles. Perhaps dark energy is the echo of that restless vacuum, the quiet hum of quantum fields woven into the fabric of existence. Yet calculations of this energy, derived from the mathematics of quantum theory, overshoot reality by numbers so vast they defy comprehension. Predictions 120 orders of magnitude greater than what is observed, a mismatch so extreme that it is often called the worst prediction in the history of physics. Others turn to speculation that bordered on the metaphysical. If our universe is but one membrane, a brane, floating in a higher dimensional expanse, then dark energy might be the pressure exerted by other branes nearby. In this vision, reality resembles a vast, unseen ocean in which countless universes drift like sheets upon the surface. Each brane carries its own physics, its own dimensions, its own stars. We live within one of these, blind to the rest, yet are still influenced by their presence. Collisions between branes could ignite creation itself. Some cosmologists suggest that the Big Bang may not have been a singular beginning, but the violent touch of two membranes colliding in the higher dimensional void. Each collision would spawn a universe, a fireball of space-time expanding outward, carrying with it the imprint of its unseen twin. In this model, our universe is not solitary, but one echo in an infinite series, each born from a cosmic impact in a realm beyond perception. The unsettling imagery deepens. If such theories hold truth, then we may be little more than one reflection in an endless hall of mirrors, each mirror cast in higher dimensions we cannot touch, each reflection unaware of the others. Our universe, with its galaxies, its stars, its history of light and life, could be but one pattern repeated endlessly across the hidden corridors of reality. This escalation of the cosmic mystery leaves humanity adrift in a sea of speculation. Dark energy does not merely stretch the universe faster, it stretches imagination itself. It compels scientists to consider that what we call existence is only one fold of a larger fabric, that the acceleration of our cosmos may be driven not by what is contained within it, but by what lies beyond. And as the galaxies race ever farther apart, carried on the tide of this invisible force, the question grows darker still. What if the expansion we observe is not a property of this universe at all, but the touch of another reality pressing against it? What if the force that carries galaxies into the abyss is not born here, but arrives from elsewhere, leaking through, from a realm we cannot see? In the fading light of distant stars, the mystery only deepens. The universe does not slow, it does not rest, it accelerates, as though drawn toward an unseen destiny. And in its restless flight, it whispers of shadows behind the curtain. Shadows of other worlds, reflections hidden in the dark. The further science has reached into the void, the more it has become clear that something essential is missing. For every luminous star, for every galaxy painted across the heavens, there exists an invisible scaffolding. Dark, silent, and strangely familiar. To account for it, physicists have begun to turn to frameworks that feel less like equations and more like mirrors, mathematical reflections of a hidden world. One of the most provocative is mirror matter theory. It imagines that nature is not broken after all, but balanced, just not in ways we can see. For every particle of ordinary matter, there could exist a twin, identical in mass and form, yet invisible, locked away in a parallel sector. These ghostly particles would interact with one another, forming their own mirror atoms, mirror stars, perhaps even mirror galaxies. The only bridge between their world and ours would be gravity, faint but universal, tugging on galaxies with invisible hands. If true, then the missing mass we call dark matter is not strange or exotic, but ordinary in its own world, an unseen civilization of matter hidden just beyond perception. The speculation deepens with the mathematics of brane cosmology, a concept born from string theory. In this vision, our universe is not all that exists, but only a fragile membrane, a brane, floating within a higher dimensional expanse known as the bulk. Other membranes could drift nearby, vast and silent, carrying their own stars and laws of physics. Should two branes collide, the shock could ignite a cataclysm of unimaginable scale, the birth of a new universe, a Big Bang repeating in endless echoes. In this framework, our own cosmos may be the scar left by such a collision, a universe, born from impact, carrying faint vibrations of the dimensions that cradle it. Beyond lies the unsettling imagery of multiverse reflections. Imagine a hall of mirrors stretching into infinity, each pane holding a distorted version of the same scene. So too might reality hold countless universes, each with its own constants, its own physics, perhaps even its own versions of life. Some would be stillborn, collapsing in silence. Others would burn too quickly for complexity to form. A few, by chance, would strike the delicate balance that allows stars, planets, and consciousness to rise. In this picture, our universe is not special, only one reflection among an infinite gallery of possibilities, an accident of cosmic geometry that just happened to awaken. Yet there are more radical possibilities still. The holographic principle suggests that everything known, the galaxies, the void, the flow of time itself, may not be fundamental at all. Instead, it could be a projection, like a three-dimensional image cast from a two-dimensional film. In this view, the deepest layer of reality is not matter or energy, but information, encoded on a distant cosmic boundary. Our lives, our history, the unfolding of the stars, may be the shadows of a code written far beyond reach. Here the word mirror takes on a literal meaning, for the universe we inhabit may be nothing more than a reflection, an echo of patterns engraved at the edge of existence. Each of these frameworks carries profound consequences. If mirror matter exists, then the galaxies we see are only half of creation, paired with galaxies that shine only in their own spectrum. If brane cosmology is true, then the dark pull of gravity may be the whisper of neighboring universes brushing against our own. If the multiverse exists, then reality itself is diluted, our sense of uniqueness scattered among infinite versions. And if the holographic principle holds, then the solidity of the cosmos is an illusion, the stars themselves shimmering images woven from information. What binds these ideas is not certainty, but longing. Longing to complete the picture of a cosmos that feels broken, longing to restore the symmetry shattered by the strange preference for left over right, for invisible over visible, for dark over light. For in every speculation, there lies the same haunting thought. What we call dark matter, what we call dark energy, what we call the unknown, may not be missing at all. It may belong to another side of reality, one that touches ours only faintly, like a shadow cast across water. The search continues. Particle detectors buried deep underground listen for the faintest whisper of collisions between ordinary atoms and their ghostly twins. Telescopes map the subtle distortions of starlight, bent by gravity, tracing the unseen structures that scaffold the cosmos. Satellites measure the relic radiation of the Big Bang, decoding the frozen ripples that may hint at interactions with something beyond. Each result tightens the noose of mystery. The universe remains tilted, incomplete, as though half of the story is being told while the other half lies silent. And humanity, gazing outward, cannot escape the suspicion that somewhere, whether in hidden particles, neighboring branes, infinite reflections, or encoded boundaries, the dark mirror waits, holding the missing half of existence. In the 21st century, the mystery of hidden realities did not fade into abstraction, it sharpened. It demanded instruments of unprecedented sensitivity, tools built not merely to confirm known physics, but to listen for whispers of the unknown at CERN, deep beneath the soil of Switzerland and France. The Large Hadron Collider circles like a buried titan. It smashes protons together at nearly the speed of light, recreating energies not seen since the first instance of the Big Bang. But in these collisions, physicists search not only for new particles within the standard model. They search for missing energy anomalies in the balance sheet of matter and momentum. If energy seems to vanish, it may not be gone. It may have slipped into another sector, a mirror world overlapping but untouchable, leaving only the trace of its absence. The detectors, layered like fortresses of steel and silicon, watch for these silent disappearances. With the patience of centuries elsewhere, deep beneath mountains and frozen lakes, vast chambers of liquid scintillator lie in darkness. These are neutrino detectors, devices so sensitive they can feel the faint shudder of particles that pass through planets as though through glass. Neutrinos, the ghost particles, oscillate between flavors, a dance long confirmed by experiments from Super Kamiokande in Japan to Ice Cube in Antarctica. But some oscillations defy simple explanation. If a neutrino disappears into silence without re-emerging in any known form, could it have slipped into a hidden twin? The possibility of mirror neutrinos, shadows of shadows, remains one of the most haunting questions of modern physics. Above ground, entire observatories listen not with light, but with tremors in space-time itself. Gravitational wave detectors, LIGO in the United States, Virgo in Europe, Kagra in Japan, stretch laser beams across kilometers of vacuum. They sense distortions smaller than the width of an atom. Most of these signals come from the cataclysmic merging of black holes and neutron stars. But theorists imagine stranger signatures still, waves born from collisions of higher dimensional branes, events that could ripple across universes like echoes across a canyon. Should such a signal ever be heard, it would not merely confirm a theory. It would rewrite the meaning of cosmic origin itself. And then there is the oldest light of all, the cosmic microwave background, the fossil glow of the Big Bang orbiting satellites. COBE, WMAP, and later the Planck mission have mapped it in exquisite detail, revealing faint ripples that shaped every star and galaxy. Yet some anomalies refuse to resolve into noise. The cold spot, a region unusually large and faint in the microwave background, has drawn speculation. Could it be the bruise of another universe brushing against ours in its infancy? A scar left on the fabric of the sky? No conclusion has been reached, but the mystery lingers, an unfinished line in the universe's story. The hunt for shadows is as much philosophical as it is technical. Science demands proof, yet how does one prove the existence of something designed to remain unseen? Every instrument stretches the limits of precision. Every dataset is combed for patterns, yet the deeper the search goes, the more the shadows seem to retreat. Physicists confront the paradox of invisibility. What if the truths that define reality are forever hidden, not by distance or faintness, but by nature itself? Still, the pursuit continues. For to stop searching would be to accept that the story of the universe is already complete, and no scientist believes that the colliders spin. The detectors wait in their silent caverns. The satellites gaze at the cold sky. Each experiment a lantern held against the darkness, chasing shadows that may be nothing or everything. The hunt is not over, it has only begun. For the silence itself has become the loudest signal, and the absence the most compelling presence. Step back from the detectors, from the equations, from the vaults of data that hum quietly in servers around the world. Step back and imagine instead a cavern. On its walls flicker shadows, cast by fires burning behind. For millennia, philosophers have returned to Plato's image of the cave, of humanity as prisoners, seeing only silhouettes, mistaking them for the fullness of reality. The allegory was ancient, yet today it resonates with startling force. If physics suggests that our universe may itself be a shadow, then perhaps we too are gazing at walls. Mistaking reflections for the true light to live in a shadow universe is not to be diminished, for shadows are not illusions. They are the shape of something real, a projection of a form unseen but no less present. The galaxies that spiral, the atoms that bind flesh and stone, the stars that burn across cosmic time, these may all be castings from a deeper order, yet they remain real to those within them. No star collapses less violently, no child breathes less fully, because the cosmos might be a mirror. Here lies the weight of the question. If existence is layered, if there are realms more fundamental, does that make ours less meaningful or more? A painting is not the original landscape, and yet the brushstrokes hold their own truth. A song is not the silence from which it was born, and yet it moves hearts as if it were everything. Perhaps the universe, too, is such a reflection, an echo of deeper symmetries, no less profound for being second in line. Science edges close to this mystery, but philosophy steadies the gaze. To imagine ourselves shadows is to confront humility, but also wonder. For shadows are not nothing. They are the evidence of form, the proof that something stands between light and absence. To dwell in a universe of shadows is to be in contact, however indirectly, with the very source of that unseen. Light, consider the night sky. The stars above may be echoes, their true fire burning beyond dimensions we cannot touch. But for us, they are all that can be seen, all that can guide across oceans and deserts, all that can inspire questions of origin and destiny. If they are shadows, then they are still our shadows, the only light we will ever know, and so the meaning does not fade, it deepens. For to live in a shadow is to live in relationship to something larger, something greater, even if it can never be reached. The cave wall becomes a cosmos. The silhouettes become galaxies. The flicker of fire becomes eternity. And humanity, still turning toward the faint glow, continues its search, not only for what lies beyond the shadow, but for what it means to live within. If the story does not close here, it cannot. For every experiment, every meditation, every whispered speculation is another gesture toward light. Perhaps one day the shadows will shift, revealing more than was thought possible. Or perhaps the shadows will remain forever, their mystery unbroken. Either way, this universe, whether shadow or flame, remains the stage upon which life unfolds. The stars may be shadows, but they are ours, and in their dim yet radiant glow, meaning endures. In the end, the search for truth returns us not only to the stars, but to ourselves. Equations may describe the hidden scaffolding of reality. Experiments may hint at dimensions beyond our reach. Yet what remains is something deeper than data. It is the recognition that even if we are shadows that think, that wonder, that dream like travelers in Plato's cave. Humanity has always reached for the light just beyond its grasp. But what if the shadows themselves are the gift? What if meaning is not diminished by being a reflection, but magnified? For in shadows there is contrast. In shadows there is form. In shadows there is story. Look upward tonight. The constellations may be projections from realms unseen. The galaxies may be echoes of deeper structures, yet they are the compass of our journey, the poetry of our existence. Every breath, every question, every fragile life has unfolded beneath their silent watch. And so, whether the universe is the first light or its afterimage, its truth or its mirror, one fact endures. It is real to us. It is enough to build civilizations, to dream futures, to carry meaning across the abyss of time. Perhaps the cosmos beyond will remain hidden. Perhaps one day its light will break through. But until then, the stars, shadows though they may be, are still our stars, and they will guide us, as they always have, into the infinite night. Perhaps We are not living in the universe at all, but only in its shadow. Like the prisoners in Plato's cave, we watch the flicker of distant stars upon the wall, never seeing the true flame that casts them. But shadows are not illusions. They carry weight, texture, meaning they shape the lives within them. If our cosmos is only a reflection, then it is still our reflection. Every galaxy, every drifting cloud of dust, every breath taken by fragile life on a fragile world is as real as anything that could ever be called real. The stars above us may be shadows, but they are our shadows, and in their glow we find light enough to dream and darkness enough to wonder. This is the shadow universe, the only one we know, and perhaps the only one we will ever need.